Hey guys, this is Coach Lo, and we are going to talk about graphing secant and cosecant. So we're going to graph y equals secant x and y equals cosecant x. Alright, so when we graph these, we're going to use our reciprocal functions to graph them. So I'm going to start with y equals cosecant x. And this graph, the reciprocal, is y equals sine x. Now, let's talk a little bit about why we're going to use this. So whatever values I have for sine on the graph, I'm going to find the reciprocal of those y values, right? And that will be cosecant. So I'm going to graph sine as my guide graph, and then I will use that to graph cosecant. So that will happen every time. We're going to do the parent functions first, but that will happen every time we graph it. The only thing that I won't graph with my guide graph is the vertical shift. All right, so I'll do those first three together. I'll do the vertical shift with my reciprocal graph. All right, so let's graph y equals sine x. I'm going to make this one blue as my guide graph. Right, so I know that sine, actually I think I'll stretch this out a little bit so you can see it a little bit better. And then on the next ones, when we start moving things around, we'll compact it. All right, so this is 1 and -1. So I have this graph here. This is in 15 degrees or in pi over 12 degrees. And so that puts 45 degrees right here in the middle. So I really like this graph paper, maybe my new favorite. All right, so we know from the unit circle that sine is the y value, and we'll start at 0, and at pi over 2 will be at 1. At pi, we're going to be back at 0, checking out that y value. And then at 3 pi over 2, we're down to -1. And then when we get back to 2 pi, we're at 0 again, and then we'll start the cycle over. So I'm at 0, I'm at 1 at pi over 2, I'm back at 0 at pi, down to 3 pi over 2, or down to -1 at 3 pi over 2, and then back to 2 pi. So this is my guide graph. All right, so I will backtrack and copy back this way. So it's moving on my unit circle clockwise. All right. So this is my guide graph. I get this little piece, of course. This is my guide graph for cosecant. All right, so I want you to think about just a few things here. For example, at pi over 6, which would be 30 degrees, sine is 1/2. The reciprocal of 1/2 is 2. So that puts cosecant here at 2 because cosecant is a reciprocal of sine. True? Same thing happens over here as it comes back down at 5 pi over 6. We should be here at 1/2. And so I'm at 2 again. Reciprocal of 1 is 1. Right? So we're here. And then let's check out some other things. What's the reciprocal of 0? It's undefined, right? So think about this for just a second. Sine, normal, just the parent function. The domain is -infinity to infinity, but my range, I stay between 1 and -1. Well, my reciprocal function is going to be greater than 1 or smaller than -1 when I move down here. Smaller than -1 because I'm flipping all these values over, right? Finding the reciprocal of those. Okay, so just something to kind of think about. All right, so when sine is 0, the reciprocal of 0, which would be 1 over 0, is undefined. So everywhere the blue graph, everywhere my sine graph hits the x-axis, I'm going to have vertical asymptotes because my function is undefined. Cosecant is undefined where sine is 0. So I'm going to go ahead and draw some vertical asymptotes that will help me guide my cosecant graph. All right, so we already put some points over here in this area, but what happens is I get really close to this vertical asymptote. So I'm going to come in from the right side of this vertical asymptote, and I'm looking at these values and I'm thinking about the reciprocal. So these are smaller than 1/2. So like 1/3, 1/10, 1/100, right? We're getting really close. When I flip those over, 1/10 flipped over is 10. 1/100 flipped over is 100. So as I move closer to this vertical asymptote, my y values for sine are getting smaller, but the reciprocal of that means cosecant is blowing up and getting bigger. So cosecant is going to move toward that vertical asymptote and toward infinity. Same thing will happen moving to the right. As we get closer here and find the reciprocal, those are shooting way up in the air. All right, let's move down here. Reciprocal of -1 is -1. Reciprocal of 1/2, -1/2 is -2. So we're down here, -2. And the same thing happens over here. Reciprocal of -1/2, -2. As I move closer to this vertical asymptote for sine, my values are getting close to 0, which means these, as I find the reciprocal of that, are going to infinity. Negative infinity, because we're coming from the negative side. All right, so I can copy these over. So I know the reciprocal of -1 is -1. We're going to go toward those vertical asymptotes. Reciprocal of 1 is 1, and I'm going toward those vertical asymptotes. All right, so the pink graph is cosecant. So I can take out the sine graph. You don't have to do this on your paper. You don't have to erase it. But I just want you to see that's actually just the cosecant graph. So that's the parent function for cosecant. So my domain for cosecant, everywhere sine hit the x-axis, I have vertical asymptotes, which means those are not in the domain for cosecant. So 1 period for cosecant is still 2 pi. So I have part of my cosecant graph going toward positive infinity and part going toward negative infinity. So that's 1 cycle. And I don't have any x-intercepts on the parent graph. It's not going to hit the x-axis. I have a y-intercept over here, but no x-intercepts. Okay, let's check out secant. Write down your questions if you have any. All right, so the parent graph for secant, we are going to find the parent graph for secant, we are going to use y equals cosine x because they are reciprocal functions. Okay, same idea here. We can use the unit circle to graph cosine. So we know cosine, when we're at 0, cosine's 1. When we're at pi over 2, remember cosine's the x value, so we're at 0. At pi, we're at -1. 3 pi over 2 back to 0, and 2 pi, we're at +1. All right, let's backtrack that. All right, so let's sketch our graph. This will be our guide graph. All right, so here's our guide graph. All right, so where cosine hits the x-axis, where the y value is 0, the reciprocal of 0 is undefined, so we'll draw our vertical asymptotes in. And then let's find the reciprocal of all these values. So the reciprocal of 1, this point is 0, 1. Reciprocal of 1 is 1. We can look here, this is 1/2. So I'm up here at 2. Reciprocal again 1/2, so I'm at 2. As I get closer to this vertical asymptote, really small y values, the reciprocal of those are going to be really big y values. So going toward positive infinity as I move toward that vertical asymptote. All right. Same idea. So there's y equals secant x. All right, so again, we can take out our guide graph of cosine. You do not have to do this. And so there is secant, y equals secant x. So you can see they look very similar, don't they? Wow, if I just move this back pi over 2, same graph, isn't it? In fact, we looked at that when we were looking at phase shifts, right? If I shift sine back pi over 2, I end up with a cosine graph. All right, I think I have time for one more. So let's move one, see if I can get this whole thing in. So let's do y equals 2 cosecant 2x plus pi minus 3. So I'm going to rewrite this. Y equals 2 cosecant. I'm going to factor out a 2, x plus pi over 2 minus 3. That way I can see the phase shift of pi over 2 to the left. All right, so I have amplitude of 2. I have period of 2 pi over 2, which is pi. Phase shift pi over 2 to the left. And vertical shift of negative 3. All right, I'm going to graph y equals 2 sine 2x plus pi over 2. And then we'll move all of them down 3. All right, so I'm going to start at pi over 2, and I have the period of pi. So that means I'm going to start at pi over 2, and I'm going to start at negative pi over 2, and I'm going to finish at pi over 2. So I'm going to start at pi over 2, I'm going to finish at pi over 2. I know that because negative pi over 2 plus pi is pi over 2. So I have a start, I have my period in the middle, and I have a stop. All right, I also know if I take the period and divide it by 4, I get pi over 4. That means I'm going to have something major happening every pi over 4. So that means at pi over 4 from here, so this is 90 degrees, so at 45 degrees, I'm going to be at 1. And then at 0, 45 degrees later, or pi over 4 later, I'm at 0. Pi over 4 later, I'm at negative 1, and then back to 0. So there's the complete cycle of sine by the time I get to pi over 2. And then I can copy these over. I'm just going to do a couple here so you can see it. Okay. So this is my guide graph. I've done everything except stretch it. Let's go ahead and put the amplitude in here. So I'm going to do everything except the vertical shift. I'm going to go ahead and stretch as well. So we had amplitude of 2. So you can see I've marked at 1, but I'm going up to 2 and down to negative 2. All right, so if you're trying to graph and you need to pause the video, yeah, go ahead and do that. All right, so here's my guide graph. Let me take these dots out of here. Okay, so this is my sine graph. I didn't do the vertical shifts yet because I want to mark where this is going to be undefined, and then I'll put cosecant in here. So undefined everywhere this graph hits the x-axis. Okay, so now I'm going to shift this thing. So we're going down 3. So instead of being here at 2, I'm moving it down 3, and this is opening up. So I look like this. I'm going to move this one down 3. 1, 2, 3, and it's going to go down. I'm going to move this one down 3, and it's going to open up. So normally it would be here, right? So we just shifted it down 3. Normally I'd be here, so I'm going to move that one down 3. And normally we would be here opening up. I'm going to move it down 3. And this is all because of my vertical shift. Down 3. And then down 3. So then we can remove this guide graph, and that's our new cosecant graph. See you soon, guys.